All right, it's good to be back with you today. You know, the last time we were together, we talked about the concept of square and the different ways of square projects. And through the years, I've thought about how important these concepts are, but this is the first time that I had a class just for that purpose. I'm glad we did it. This is the last video of our raised garden bed assembly videos. Next week we'll do the setting the beds, filling them up, finishing them up. I have some more videos putting some raised beds together today. We got a special guest appearance, and we want to cover our last objective today in this series. It's calculating angles for polygons. We'll learn how to find those angles. So let's get started on that. Well, I had to work out a few kinks after the first bed, but the second one went a lot smoother. I ended up making, when it was all said and done, I had one 16 inches high, built a couple 12 inches high, made a few 8 inches high, and if I have enough material left, I think I'll make one more. But in this video coming up, I made one 8 inches high. On my first box, I had a jig that I made. Well, here it is. For finding the location for us to drill. It was measured from the outside to the center. I run into some problems. The holes weren't lining up because a lot of these timbers, they're not the same size. I was measuring over. You know, it's measuring a quarter from the outside, and so some of them just they wasn't lining up, and I was having problems trying to drive a rebar through. So I come up with drill jig 2.0. This one measures from the inside. You're gonna get the center because the inside is gonna be true. They always gonna come together right here in this lap. No matter whether one sticks over a little farther than the other one. If I get my measurement from here out on each one, it's going to be the same. And I can mark them to get the center, but we're hoping we're going to have a lot better result. All right, now we can get the second layer. I'll mark our holes. I made sure we got our inside corner matching up real good.
Done.
As much as we have discussed the importance of squares in 90-degree angles, there are times when square is not the goal. Some projects call for specified shapes that are not 90 degrees. Those shapes require specific angles. One example would be making segmented bowls, something we've done in our shop. You take a frame and you make layers and you glue them together. When it's done, it'll look something like this. Then you put them on a lathe and you turn it, smooth it out, and it'll look like this. Here's the finished product of a bowl that we made. We designed it and made it in our shop. And we did all this using different shapes. I think this was a 12-sided polygon. So each ring had 12 sides, and we had to determine what angle to cut them all on. Let's take a minute for math and discuss a little geometry. What is a polygon? A polygon is a closed shape made with 3 or more straight lines. All right, so let's look at some examples and decide whether they're polygons or not. Is that a polygon? It's a closed shape. It's got straight lines, 3 or more. Yes, it's a polygon. How about this? Closed shape made with 3 or more straight lines. What about this shape? No, it's got curved lines in it. Oh, let's take this star shape. Straight lines, more than 3. It's closed. Yep. This shape? No. Got curved lines. And this shape? Yes. All right, so how about regular polygon? A regular polygon is any closed shape with 3 or more straight lines. That's the definition of a polygon. All sides are the same, and all angles are the same. So, is this a regular polygon? It's a polygon, but all sides and all angles aren't the same. How about this shape? All sides, all angles, they're the same. So, yes. This shape, that's a square. It's got 90-degree angles. But yes, it's a regular polygon. All sides and angles are the same. How about this? It's a right triangle. It's got 90 degrees. But no, all angles aren't the same. All sides aren't the same. How about this case? This is not a regular polygon because all the sides aren't the same. Now in this situation, all the angles are probably, I think, are the same, but all the sides are not. So it's not a regular polygon. In this shape, all sides and all angles are the same. So it's kind of simple. That's a regular polygon. With a regular polygon, no matter how many sides you have, the cut angles can be easily determined. How do you find the angles? That's determined by the number of sides. This is a regular polygon we're familiar with. It's an octagon. It's a common shape used in construction. Here are some examples of how it's used. How many sides does the octagon have? It has 8 sides. This is an exterior angle. If you add up the degrees of all the exterior angles, it equals 360 degrees. So to determine the angles of any regular polygon, just divide 360 by the number of sides. The octagon has 8 sides. So 360 divided by 8 equals 45. So this angle is 45 degrees. 360 divided by 8 equals 45. 45-degree angles will be made by 2 cuts, as you can see. These are called miter cuts. It'll be 1 cut on each board. So for the miter cut angles, divide 45 by 2, because it's a 45-degree angle that we're making, but we're using 2 cuts to make it, here and here. So we would divide that 45 into 2 cuts. So the miter cuts on each board will be 22.5 degrees. Let's take a minute to go over what regular polygons are. Make sure we understand the characteristics of them. Which of these are regular polygons? Just write yes or no. If you got a worksheet, use it. If it didn't do copies of the worksheet, just write down 1, 2, 3, 4, 5, 6, 7, 8 and write your answer beside it. Pause the video and continue when you're ready. Okay, let's review your answers. What makes a regular polygon a regular polygon? All sides are the same and all the angles are the same. That's what makes it unique. So, number 1. No. Clearly see all the sides or all the angles are not the same. All right, how about number 2? All the sides are the same and all the angles are the same. So yes. Number 3. It says all the angles are 90 degrees. It sounds like it ought to be something special. It's square, but it's not a regular polygon. All the angles are the same, but all the sides are not. Okay, here, number 4. All the angles are the same, but all the sides are not the same. It's not a regular polygon. Number 5, how about this one? Okay, all the sides are the same. It's square. And all the angles are the same because it's telling us this diagonal is 5 and this diagonal is 5. So yes, it's a regular polygon. Number 6, all the sides are the same length, but these angles are not the same. So no. All right, here we got a polygon that all the sides are the same, so that's going to make all the angles the same. So yes. And here we have the 3, 4, 5 triangle. So this is a good way to do what? Make sure something's square, but it's not a regular polygon. Now let's look over these shapes and angles and answer these questions concerning them. The first one is, what is the sum of all the exterior angles of a regular polygon? Then, what are the exterior angles of these regular polygons? So this is the exterior angle. It will be on each one. So give me that angle for each one of these. Next question, what is the angle of the miter cuts for these shapes? All right, your miter cuts, remember, will be cut. It'll be two cuts, one on each piece of wood if you're building a frame. So how do you get that? Remember the exterior angle. This is the exterior angle here. So whatever that exterior angle is, like right here, you would do what? Divide it by 2, because you're making 2 cuts to make 1 angle. So divide your exterior angle by 2, and that'll give you miter cut angle. Do that for these. And last is, what is the difference in a polygon and a regular polygon? Okay, pause that video, and we'll continue later. Now that you have completed answering these questions, let's review it real quick. All right, so, excuse me. What is the sum of all the exterior angles of a regular polygon? Remember, here's the exterior angle. If you added all those up together, this exterior angle, that one, that one, that one, all of them all the way around, what will it equal? (360 degrees). No matter how many sides it's got. When you add them up, it'll be 360 degrees. All right, what are the exterior angles for these polygons? All right. Well, it's got 8 sides, so 360 here divided by the 8 sides equals 45. So remember the formula for finding the exterior angle of a regular polygon is take 360 and divide it by the number of sides. Simple. All right, for this shape here, we got 10 sides. So what do? 360 divided by 10 is 36 degrees. Number 4, it's got 6 sides, 60 degrees. And number 5, it's got 12 sides, 30 degrees. Okay, what's the angle of the miter cuts for these shapes? Remember, this is the octagon, this is the octagon. So 45 is your exterior angle. We said divide that by 2. 45 divided by 2, 22 and a half. All right, number 7. How many sides? It had 10 sides, which made the exterior angle 36 degrees. 36 divided by 2 is 18. And number 8, which is a square. The exterior angle is 90 degrees, so the miter cut will be 45 degrees. All right. Next, what's the difference in a polygon and a regular polygon? We talked about that a couple times. A polygon is a closed shape with 3 or more straight lines. But a regular polygon is a polygon, so it's going to have closed shape with 3 or more straight lines, but all sides are the same and all the angles are the same. All right, let's move on. So now let's build our bump out raised garden bed. I had one more raised garden bed to build, but it was necessary to make a design modification in order to incorporate an existing shrub. Or in my words, I made some changes because there was a bush in the way. This is a drawing that shows what our next project will look like. So we need to determine what angles we need to make the cuts. In this raised bed, we use the shape of an octagon. So we need to find the exterior angle of this octagon. So we know our octagon's got 8 sides. Find the exterior angle. We need to divide 360 degrees into 8, and that gives us 45. So we know this exterior angle here is 45 degrees. To get our miter cuts, we'll make a cut on each board that makes this 45 degrees. We divide 45 by 2, and we get a 22.5 degree angle on each side. That'll be our miter cuts. All right, we got to make a few 22.5 degree cuts. Right there, that'll work. All right. I staggered these where the timber from the main part of the bed butt here, lap over the top. That way we can drill a hole. And when we get it together, we'll look something like that. Be a 45 degree angle. Screws in there. Should do it. We had a very special and distinguished guest to make an appearance on our video today, Dr. Emmanuel Austin. And I'm hoping when the word gets out, the ratings of our show is going to skyrocket. This could double our viewing audience in a short time. I'm looking by next week, possibly have as many as 10 views, maybe even pick up a couple likes. We're going places.
Hey, this is Dr. E here. I'm working with Mr. Boswell today, and we are together creating these raised garden beds. I'm not a carpenter, but I'm trying to follow along and see how well I could do. I've already started practicing on some cuts. I have here this 8-foot piece of landscape timber. I'm going to now cut it in half so I could have my 4-foot piece of timber. And one of the tools Mr. B talked about in his video was using this Sawzall. So I have this Sawzall here that I've used, and one of the things that I did notice is when you're using this thing, and particularly when you're an unskilled carpenter such as myself, you gotta be very careful. It wobbles. So just take a look at this. This is one thing you gotta be very careful of. See how that blade begins to wobble back and forth like that, which can really mess up your cut. So that's one of the things that I noticed as you're putting this together. You got to be very cognizant of because it will definitely mess up your cut.
All right, well, that's a wrap on putting the raised garden beds together. I ended up building a 6 in all. Like I said earlier, I might still build one more. Next time, I'll show you how we set them in place. And we'll do some math on area and volume. I bet you're getting excited already. Can't wait, right? But you need to be taking notes because in carpentry, math's a big part of where your money is. All right, we'll talk a little bit next week about leveling. We might demo the laser level. And I'll show you some pictures of the finished product. Might have a little tomato on the vine. Y'all take care, and I'll see y'all next time.